Hey guys, so far we have learned 10 questions from various topics in soil mechanics like basic properties of soil, consolidation, shear strength, compressibility, and also some questions from foundation engineering also. Now we shall move on to permeability of soil. We shall see the concepts uh, that are covered in permeability of soil. Now let's start with the first question. This question deals with the factors affecting permeability. Permeability of soil depends on which of the following factors. Option A, adsorbed water. Option B, degree of saturation. Option C, foreign impurities. Option D, head causing flow. So among four options are four factors, which the following factors um, are affecting the permeability of soil. So option A, adsorbed water and degree of saturation and also foreign impurities are some of the factors affecting permeability. Now we shall see what are the other factors that are affecting permeability of soil, or the permeability of soil depends on the following factors like this. So before moving to the factors, we shall see what is permeability. It is nothing but the ease with which water flows through soil. For example, this is a soil sample. In the soil sample, we have solid contents, void contents. In the void, there will be water and air. So water flows through these voids. So this is the permeability, we can say. The ease with which water flows through the soil. So it is a property of soil. So permeability is the ease with which water flows through the soil. It depends on particle size and particle shape. If the particle shape is like angular or tightly packed, then permeability will be less. And particle size also affects the permeability. And next, the fluid flowing, that is the pore fluid. In this case, we can consider water here. So properties of water, adsorbed water. Adsorbed water means, consider this is a solid particle above which there is a layer of water, that is called adsorbed water. That is a concept of adsorption principle. So that's why it is called adsorbed water. And the minerals present in water, for example potassium, sodium, calcium, these will affect the permeability of soil. And also the temperature. How temperature? The permeability is inversely proportional to the viscosity of the fluid flowing through the soil sample, and the viscosity is inversely proportional to temperature. For example, this is viscosity is inversely proportional to temperature, and the permeability is inversely proportional to this viscosity. Then what that means, if the temperature is more, then permeability will be more. So that is the temperature dependence. And next is the structure of soil. So structure of soil affect the permeability of that soil. And also the void ratio and entrapped gases. If there is more entrapped gases, then permeability will become less. So these are the dependent conditions which affect the permeability of soil. Now we shall move on to the next question. This question deals with the variable head permeability test. In falling head permeability test, the head causing flow was initially 75 centimeter, and it drops by 12 centimeter in 8 minutes. So after 8 minutes, initially the head causing flow was 75 centimeter, and it drops by 12 centimeter in 8 minutes, and the total time in minutes required for the head to fall to 30 centimeter. So 75 to 30, how much time is required? That is asked. In minutes, we have to calculate. So option A 38 minutes, option B 8 minutes, option C 42 minutes, option D 2523 minutes. So what is the time required for the head to fall to 30 centimeter? We have to use the concept of variable or falling head permeability test concept. Here the correct option is option C 42 minutes. Now we shall see the calculation part and the formula used here. The falling head permeability test. Before moving to formula, we shall see when falling head permeability test is applicable. It is applicable for fine sands and silts, which have relatively low permeability. A soil having very less or low permeability, then we can go for falling head permeability test. If a soil sample is containing more amount of uh, coarse grained particles, then we can move for constant head permeability test. And the constant head permeability test is based purely on the Darcy's law. we shall see the Darcy's law in upcoming questions. Now here we shall consider the variable head permeability test, and coefficient of permeability is given by K is equal to 2.303 AL by AT log of H1 by H2. So what is A? Small a? Small a is the area of this standpipe, cross-sectional area of standpipe. What is L? L is the length of soil sample. And what is a capital A? Capital A is the cross-sectional area of soil sample. And what is T? T is the time required to fall from head 1 to head 2. The time required to fall head 1 to head 2. So this we have to apply the relevant data over here to get the answer. So here we can see this A, length of the sample, area of standpipe, area of soil sample, these parameters will remain constant for the both head falling, like a H1 to H2 and H2 to H3. So that is why we are considering all these parameters as a constant one, so that we can equate that as a C constant and divided by T log of H1 by H2. And here we know that H1 is equal to 75, H2 is equal to 63. How? Because it is dropping by 12 centimeter. It is not dropping 2. We have to be careful of 2 fall or by fall. It is 2 centimeter means then the head will be 30. It is by 12 means then we have to cancel out, like we have to subtract 75 by 12. So that's why head 2 is 75 minus 12, 63, and this 75 to 63 time taken is 8 minutes, or we can convert it to seconds for easier calculation, and for dimensional homogeneity 480 seconds. And here we can substitute all the parameters we know here. So C by 480 log of 75 by 63 equal to C by T. This T we have to find, and log of 75 by 30. So we have to find the time required for the head fall from 75 to 30. So just substitute all the relevant data and parameters here, so that we can get the answer for T in seconds, that is 2523 seconds, and we have to calculate in minutes as mentioned in here. So seconds to minutes as 42 minutes. This is how we have to proceed with a variable head permeability test. So this is the main and important formula. K is equal to 2.303 AL by AT log of H1 by H2. That's it. This question deals with the permeability in soil strata. Here the flow is in vertical direction, and we have to calculate the total head loss in 3 layers. So consider the 3-layered soil strata shown in the figure. So here we can consider the first layer, second layer, third layer, and the corresponding depth of the layers and corresponding permeability of those soil layer. And we have to calculate the total head loss. Option A 1.52 meter, option B 1.23 meter, option C 1.18 meter, option D 0.87 meters. So by using average permeability in vertical direction, we have to find the permeability, that is average permeability. After that we have to use one concept that we will see. So here the answer is option C 1.18 meter. How to calculate that? The average permeability in vertical direction is given by this formula. Kv is equal to h, that is total depth of the given soil strata as 9 meter, divided by h1 by k1 plus h2 by k2 plus h3 by k3 up to the n layers. And we know what is h1, k1, h2, k2, like that. Just to substitute all the given values here, so that we can get the answer for kv, that is average permeability in vertical direction, as 1.33 into 10 power minus 3 centimeter per second. So we calculated the average permeability in vertical direction because the flow is in vertical direction, and we have to use the continuity concept here, so that we can find the total head loss. So for continuity, velocity should be remaining same. So what is velocity? So if we see Darcy's law is Q is equal to KIA. That formula we shall see in the upcoming question, but just now consider this one. The discharge is given as K into I into A. So discharge is nothing but the velocity into area. So for example, V into A. So area cancelled out. So velocity is nothing but K into I. So what is I here? I is nothing but hydraulic gradient. Now we shall consider this diagram. Here they have given in the third layer they have inserted the piezometer, two piezometric pipes with a level difference of 2 meter. So this is the capital L value, and the head loss between the two piezometer connected to third layer is given as del H is equal to 0.5 meter. And then what will be the hydraulic gradient? Del H by capital L. And since this is connected in a third layer, so that's why K3 into del H by L. That is K into I is del H by L, equal to the average permeability in vertical direction into the total head loss divided by total height of the three soil layers. So we know K3, del H, capital L, KV and capital H. So among substituting all the values over here, we can find the value of del H total, that is total head loss in the three layers, as 1.18 meter. So here the concept followed is continuity concept, that is velocity remains same. Now we shall move on to the fourth question. This question deals with Allen-Hessen equation. Approximate ratio of the permeability of two clay soils having D10 values of 0.8 mm and 0.4 mm respectively is. What is D10 here? D10 is the effective diameter of particle size, or the particle, effective diameter of the particle in the soil sample or in the two clay soils. D10 given as 0.8 and 0.4 mm. We have to calculate the ratio of permeability by using just D10 value, because we know that particle size will affect the permeability of the soil. So here the answer, that is the ratio of permeability of those two clay soils, is 4. Now we shall see how it is calculated. Here we have to use Allen-Hessen equation like K is equal to C D10 square, where capital C is the Hassen's constant. Usually this K equal to C D10 square Allen-Hessen equation is applicable for granular soils, but yet here the question in this question they have mentioned as clay soils. Because of unknowing, because other data are unknown, we shall use conservatively here like K is equal to C D10 square, so that we can find the ratio of permeability of two clay soils. And coming to Allen-Hessen's constant, this constant varies from 100 to 150 usually, and this D10 size has to be substituted in centimeter because this equation is the empirical one, and the permeability value should be in centimeter per second. Now coming to other empirical equations and formulas regarding permeability, we shall see one by one. First one is Kozinnik-Kármán equation. This is the most important equation we have to follow for any given soil. K is equal to 1 by K suffix K into E cube by 1 plus C gamma W by nu D10 square. So what is here K suffix K? This is a Kozinnik-Kármán constant, as like we have seen in the Allen-Hessen. C is the Hessen constant. Similarly, Kk is the shape factor. We can also say like it's a shape factor or Kozinnik-Kármán constant. And small e, we know that is a void ratio, and gamma w by nu, this is a fluid property. Gamma w is the unit weight of water, divided by nu is the dynamic viscosity of the water. Or if any other fluid other than water is flowing, then we have to consider those properties of that fluid, like for example, uh, apart from water we are considering any kerosene, then unit weight of kerosene divided by the dynamic viscosity of kerosene, uh, respectively. We have to consider the unit, we have to consider the properties of the fluid flowing in a pores. And D10 is the effective size of the particle diameter, and this formula is the most important one, so that we can consider for any given soil. Next is the consolidation equation. This equation we have dealt in the consolidation chapter. You can refer this suggested video so that you can get an insight on consolidation and how this formula is used, and what is MV, what is CV. You can get it in that consolidation video. Moving on to Laurent's equation, this is given by log of K A square equal to A plus B n. This small n is nothing but the porosity, and K is the constant. A and B are given here. A is equal to 1.365, B is equal to 5.15 at 10 degrees Celsius. These are Laurent's constants, and n is the porosity, and capital S is specific surface area, or area per unit volume, we can say like that. Specific surface area is given as 6 divided by root of AB. So this is the Laurent's equation. This K is the constant or the coefficient of permeability. We have to find using the Laurent's equation. And next is the Terzaghi's equation. This is given by K is equal to 200 E square into D10 square. Here also we have to substitute D10 in centimeter and K in centimeter per second. These are some of the most important empirical formulas, and among these, this Kozinski-Karman equation is the most important one we can expect in many examinations. Now we shall move on to fifth question. This question deals with the absolute permeability concept. Coefficient of absolute permeability depends on fluid properties like viscosity and unit weight, whether this statement is true or false. We have seen the we have seen the dependent factors that is affecting the permeability. Here they have mentioned as absolute permeability. So coefficient of absolute permeability depends on fluid properties or not? No, it is false. Coefficient of absolute permeability does not depend on fluid properties. It only depends on the soil properties. So that is why this statement is false. Let's see what is coefficient of absolute permeability. This is denoted by K naught is equal to K into nu by gamma W. In K formula, we have gamma W by nu. So gamma W by nu into nu by gamma W cancelled out. So that is why coefficient of absolute permeability is not depending on fluid properties. Coefficient of absolute permeability is depending only on the soil properties like void ratio, shape factor, D10, as we have seen in the Kozinski-Karman equation. And the coefficient of absolute permeability has units of area like meter square, or we can say Darcy, and 1 Darcy is equal to 0.987 into 10 power minus 8 centimeter square. This is the Darcy units for coefficient of absolute permeability. And we can also call this absolute permeability as intrinsic or specific permeability. And let's move on to Darcy's law. We have already discussed in the one of the previous questions. Now we shall see in detail. Darcy's law states that the discharge in the soil is directly proportional to hydraulic gradient and the cross-sectional area of the soil. So what is hydraulic gradient? The head loss divided by the length of soil sample, del H by L into A. So upon cancelling out the proportionality constant, we get the coefficient of permeability as K. Q is equal to K into del H by L into A, and this can be denoted as I, that is hydraulic gradient. And we know that discharge is equal to velocity into area. So that is why velocity or discharge velocity is equal to K into I, simply K into I. And K is nothing but the K has units nothing but same as velocity that we see here. Coefficient of permeability is defined as the average velocity of flow. This is actually the velocity of flow when we consider unit hydraulic gradient. Simply we can say coefficient of permeability is the average velocity of flow which will occur under unit hydraulic gradient. So simply this is nothing but the velocity of flow under unit hydraulic gradient, and the unit is nothing but as the velocity, centimeter per second or meter per day or like that. There are some limitations in Darcy's law. This Darcy's law is applicable only when the only continuity concept is followed. So that's why we have applied continuity concept in one of the previous question. We have seen like K into del H by L is equal to K V into del total head loss divided by total height of the strata. So that we have already seen the continuity concept. That is velocity remains same. And next is the steady state laminar flow. So the flow through the soil should be laminar, that is nothing but the Reynolds number is always less than 1. Then only we can apply this Darcy's law. Next condition is the saturated soil. So the soil has to be fully saturated. There should not be no air voids. So that is a condition to apply Darcy's law, and there should be no volume changes in the soil. occurring. That means there should be no swelling or sinkage. These are the important things regarding Darcy's law and absolute permeability. Now we shall move on to, before moving to the next question, we shall see this table also. For example, the soil type is clean gravel, then we can expect the coefficient of permeability as 10 power minus 1 to 10 power plus 1 to 10 power 2 millimeter per second. That means the drainage properties are very good. That is, it cannot hold the water. The water in the soil or in the clean gravel will be draining out very fastly in the rate of 10 to 10 power 2 millimeter per second. If we consider coarse and medium sand, then the permeability will be around 10 power minus 2 to 10 power plus 1 millimeter per second. So we can say it is having good drainage properties. And for silt and sand like this. So in case of very silty clay and very having a high modularity content and swelling shrinkage properties, we can expect a very less coefficient of permeability of around 10 power minus 8 to 10 power minus 5, which is very poor. That means it is holding the water. It is not allowing the water to pass off. So these are the things regarding permeability and absolute permeability Darcy's law. Now we shall move on to next question. This question deals with again falling head permeability concept. Which one of the samples has internally inconsistent data? So here we have A, B, C, D as 4 samples, and for the 4 samples, the time taken from one head to another head is given in this table. We have to consider all the data so that we can get which sample is inconsistent. The sample's data is inconsistent. Here the sample C is inconsistent. We shall see how do we know this inconsistency. For the data to be consistent, this relation should be satisfied. H1 by H2 is equal to H2 by H3 is equal to H3 by H4 is equal to H4 by H5. Like this, the data should be followed, or the falling head should be following this trend. So that means the falling heads following geometric progression. H2 square is equal to H1 into H3. That is, the second falling head, square of the second falling head should be equal to product of previous and the next one. Simply we can say H2 square is equal to H1 into H3. So we have H1, H2, H3. So 32 square is equal to 40 into 25.6. So that is satisfied. That means sample A is consistent. Samples A's data is consistent. Similarly, for sample B, 30 square is equal to 40 into 22.5. But for sample C, we observe that 20 square is not equal to 40 into 12. So that means the sample C has inconsistency in the data or the falling head that already observed. So here sample C is inconsistent. So the concept followed here is this one. The falling heads are in GP. That is, the second fall head, square of that second head shall be equal to the product of previous head and next head. H2 square is equal to H1 into H3. Now we shall move to 7th question. In two-dimensional flow situation for an anisotropic soil, anisotropic means properties varying in directions. The permeabilities of soil in x and z direction is given as 32 units and 8 units respectively. So we have to calculate what is the effective permeability. Since the soil is anisotropic, there will be difference in permeabilities in different directions. They have given x and z direction permeability values. We have to calculate the effective permeability of the soil. Here the answer is option A, 16 units. Now we shall see how it is calculated. Since the direction given are only 2, that means it is a two-dimensional flow. For two-dimensional flow, k equivalent shall be given as root of kx into kz. We know kx and kz values, that is 32 into 8, that become to 56. So root of 256 is 16. And in case of three-dimensional flow, for example, we are given like a x, y, z direction, then we have to use this equation, this formula to find the K equivalent as the cube root of Kx into Ky into Kz. It's a simple and but yet a most yet important formula to find the equivalent permeability, as we have already seen in average vertical permeability and horizontal permeability. Similarly, it is like this equivalent effective permeability. Apart from that, we shall see some dependencies in water, presence of minerals in water. This dependent factor we have already seen in the first question. We shall see some more points about minerals in water. If the void ratio is constant at any cost, the permeability is increased in this order. For montmorillonite mineral in the clay, if potassium is there, then that has a very less permeability, then sodium, then hydrogen, then calcium ion. So these are the minerals in water present. If potassium is present in a montmorillonite clay, then permeability will be very less when compared to sodium and compared to hydrogen and compared to calcium. Similarly, for kaolinite clay, if sodium is present, sodium is a dependent mineral in that water, then permeability will be less. So in a sodium less than, potassium less than, calcium less than hydrogen. This is the trend that will follow for permeability that will be affected by minerals present in the water. This is one extra uh, information that we have to be aware of. Now we shall move on to eighth question. This question also dealing with soil strata. Option A, head loss is same in horizontal direction. Head loss is same in vertical direction. Discharge is same in horizontal direction. Discharge is same in vertical direction. You can closely observe these two diagrams, vertical flow and horizontal flow. By observing this diagram, you can say like head loss is same in horizontal direction, because uh, at every uh, section, if for every layer there will be different discharge, but there will be head loss which are same. And in case of vertical direction, discharge will be same, because whatever the water present here, that will be discharged to second layer, the same will be discharged to third, same will be discharged to next layer. So discharge is same in the vertical direction, but here discharge is the sum of all the discharges in each layers, but here the head loss is same. Now we shall see the average formulas regarding horizontal and vertical direction. We have already seen this formula. Now we shall see the average permeability in horizontal direction. KH is equal to sum of the products of permeability and layer depth divided by the total head, or the total we can say total height of the layers considered. This is the average permeability in horizontal direction. This diagram refers to the horizontal flow. This diagram refers to the vertical flow. For vertical direction, this formula that we have already seen. And in any case, horizontal direct, if for in any case, the KH in horizontal direction is always greater than average permeability in vertical direction. So that means if the flow is in horizontal direction, then permeability shall always be more when compared to the same flow in vertical direction. So KH is always greater than KV. So these are the two important formulas from soil strata. Now we shall move on to the next question. Coefficient of percolation is given by, this is a simple concept regarding coefficient of percolation, coefficient of permeability and porosity. N is the porosity. So how coefficient of percolation and porosity and permeability are related? Correct option is option A, Kp is equal to K by N. Similarly, we have seepage velocity. The seepage concept we shall see in the next video. In this video, we are only covering the permeability concept. So we shall see this seepage velocity alone. Seepage velocity is given as V by N. V, we know it is a superficial velocity, or we can say discharge velocity, that we have already seen in the Darcy's law. That is Q is equal to KIA or V equal to KI. So seepage velocity is Vs by equal to V by N. This porosity value shall always be less than 1. So that means Vs, or the seepage velocity, is always greater than the discharge or superficial velocity. Similarly, coefficient of percolation is always greater than coefficient of permeability, since porosity value is always less than 1. Now we shall move on to last question, which is yet an important one. We have already seen the permeability test by conducting constant head permeability test for high clean gravel soil or sandy soil, variable head permeability test for clay soil, and there is another test called capillarity permeability test. Now we shall see that now. A capillarity permeability test was conducted in two stages under a head of 60 centimeter and 180 centimeter. So two stages are there in capillarity permeability test, and for two stages they have given the head values. In the first stage, the wetted surface moved from 1.5 centimeter to 7 centimeter in 7 minutes. So the wetted surface, the head is moving from 1.5 centimeter to 7 centimeter in time taken to move this head is 7 minutes. And similarly for second stage, 7 to 18.5 centimeter in 24 minutes. They have given the degree of saturation and porosity values at the end of the test. We have to find the permeability and the capillarity head. So permeability and capillarity head we can find using this capillarity permeability test as a one of the important tests apart from constant head and variable head permeability test. Here the correct options are A and B. We shall see how these are calculated. A simple equation to be followed here. First, we shall write the given data like this: stage 1 and stage 2. For stage 1, head from 60 to 180. That is noted as H01 and H02. And x2 is 7 centimeter, x1 is 1.5. X2 is the final wetted surface moving to 7 from 1.5. So that's why x1, x2 is noted like this. And time taken to cross these surfaces 7 minutes. And similarly for stage 2, we have x2 dash, x1 dash, like that. T2 dash minus T1 dash is 24 minutes. S is equal to 85%, N is equal to 35%. We have this formula in capillarity permeability test. We have to follow this, simply substitute all the given data over here to get an equation like this, and in second stage also given data over here to get an equation like this. By solving these two equations we get the answer for K and HC. So we shall see the equation now. X2 square minus x1 square divided by 2 t2 minus t1 is equal to 2k by sn into h01 plus hc. So we know x2, x1, 7, 1.5, t2 minus t1 is 7 minutes, and 2k by sn. We have to find the value of k. S we know degree of saturation, n we know porosity. Both the values are given. H01 is 60 centimeter, initial head is 60, and it is under a head of two heads, like one head is 60 and another head is 180. So that head will another head will be substituted in second stage. So that's why H01 plus HC. So upon substituting all the values over here, we can get two equation. By solving these two simple linear equation, we can get the simultaneous equation. We can get the value of K and HC. So this is how we have to go with the capillarity permeability test. So we are at the end of this video. We have seen almost all the concepts in and concepts formulas in permeability of soil. Please subscribe the channel. Thank you for watching, and you can also see these two suggested videos. Thank you for watching.